Okay, hello folks. We are going to go ahead and start jointly sections 7.4 and 7.5, which is when we really kind of get into the meat of logarithms and their properties. The homework assignment is going to be this worksheet 7475A, but for this first day, these are the only problems that I want you to complete. We won't be completing the entire notes page here today. In the next video, we will finish the rest of the notes, and then your assignment would be to finish any of the remaining problems that I'm not asking you to do on the worksheet here. Okay, so you can see on this notes page, there are a lot of different logarithm properties here, and you don't have to worry about memorizing the names of the properties or generically how these properties look. I think what's important is that you're understanding how you can use the properties to simplify logarithms. Okay, so I want to start over here with what you see on the right side here that's talking about the circumstances that have to take place in order for you to be able to combine two logarithms together. Okay, there are essentially two requirements that have to be true of your logarithms in order for you to be able to combine them together. And one is that those two logarithms have to have the exact same base. Okay, so if they have completely different bases, you are not able to combine those two logarithms together. The second requirement is, in order to combine two logarithms together, each of those logarithms have to have a coefficient of 1. Okay, there has to be a 1 in front of those logs. So what we're going to be working through here today is we're going to talk about one of these properties, and then we're going to jump down to the bottom so that you can see how that property looks in an actual example, and then we'll come back up and talk about another property, and then we'll go back down and do another example here. So let's start with the property called the product property. And you can see that I've listed the property pretty generically. There's not a lot of numbers in these examples. I think it's a little bit easier to look at an example that has some numbers in it. And so these blank lines that you see underneath, I'm going to have you fill in a specific example so that we can see how these properties look in action here. Okay, what the product property is telling you is it's showing you how you could add together two logarithms. So I'm going to have you fill in on this blank here, log base 3 of 5 plus log base 3 of 2. Okay, now if we're trying to add these two logarithms together, remember over here we said in order to combine two logs, we have to make sure that these two requirements are met. One, they have to have the same base, which these both do, and two, those two logarithms have to have a coefficient of 1. You can see there's a 1 that would be in front of here as well as here. So it meets both of those criteria. So according to this property, to add the two logarithms together, what you're actually going to end up doing with the arguments of the logarithms is you're actually going to end up multiplying those arguments together. So the base is going to remain the same, log base 3, but then the new argument is going to be a 10. Okay, so that's why this is called the product property, but it's actually what you're doing when you're adding two logarithms together. Okay, so let's come on down to example number 1, part A here. And you can see that the directions are asking us to write each expression as either a sum or a difference of logarithms. And then they want us to simplify if possible. So in example A, this is just one single logarithm. We can see we have log base 3 and the argument is 8xy. Okay, and so we're wanting to kind of break this apart into two different logarithms. Okay, and it actually is the reverse of this property. It's like starting over here, and we would factor the 10 into any two numbers that would multiply to be 10, and then we would split those apart over here as the arguments. So there's lots of different correct answers to this. One answer would be to say log base 3 of 8x plus log base 3 of y. Okay, that would be acceptable because we know if we were to recombine these together, if we're adding logarithms, we're actually multiplying their arguments. I'm going to go ahead and write a second example here. Okay, it would be log base 3 of, we could say 2x. Now if I made that argument a 2x, let's think about what this other logarithm's argument should be. Okay, if that's a 2x, then over here I would need this to be a 4y, so that if we multiplied these two arguments together, it would still multiply to be that 8xy. Okay, and there's some other options of different ways you could separate this. This is totally fine to break it apart into either of those two. Okay, let's go ahead and jump down to the next set of examples here. Example 2, we're going to look at part A, and here we're going to go the other direction. You can see that we're starting out here with 2 logarithms, and the directions are asking us to now express this as a single logarithm, and then to simplify if possible. Okay, so we can see that we are adding these 2 logarithms together, so we have to make sure that we meet this criteria up here. The 2 logarithms have to have the same base. They also both have to have a coefficient of 1. Let's check that. I see they both have the same base of 2. Also, looks like the coefficients for each are 1. So I'm going to go ahead and actually multiply their arguments together. That would give me an answer of log base 2 of 35. Okay. Now you'll notice the tail end of the directions here are asking us to simplify if possible. Some of these answers we're coming up with, we're going to be able to simplify further, but not until we talk about some of these properties up above here. So let's come back up to the top and let's take a look at this property called the quotient property. Okay, you can see here this property is showing you how to combine 2 logarithms if you're subtracting them. So let's fill in log base 8 of 7 minus log base 8 of 2. Okay, now this is a subtraction sign here in the middle. So this, we still have to meet these same 2 requirements. The bases have to both be the same. The lead coefficients, or the coefficients rather, in front of the logs have to be a 1. And if it meets that criteria, then when you combine these logarithms together, you're actually going to take the first logarithm's argument and you're going to divide it by the second logarithm's argument. So 7 divided by 2. Now, if when you create that fraction, if that fraction can be reduced or simplified, you would want to do that. Like if this was an 8 and that was a 2 and you had 8 divided by 2, you would go ahead and make the argument a 4 then. Okay? All right, so let's put this into action down here with example 1, part B. Again, the directions are asking you to separate this single logarithm into either a sum or a difference of 2 logarithms. Well, if your argument has things multiplied together, we separate it with addition. But if the argument is a fraction where we're dividing things, then when we separate this, it has to be the numerator comes first, minus, then we put our second logarithm here, the denominator comes second. Okay? So that if we were to do this problem in reverse and recombine these together, we would get back to what this original problem is. Okay? Now there is a little bit of simplifying that can happen on this problem, so I'm just going to kind of highlight example B, and we're going to come back and revisit how to simplify this part of that problem once we talk about one of the properties up above. Okay? So let's jump on down to example 2B, go the other direction with this. Here we're given 2 logarithms. We're trying to subtract them. We want to try to combine it together as a single logarithm. Now again, make sure the bases are both the same. Make sure they have coefficients of 1. Okay, it meets that criteria. So we're going to say combine together. This would be log base 2 of 5/7. Okay. Now look at the example underneath that one. Here we've got 3 logarithms. Actually, I think we might need to talk about one of the properties up above before we do this here. So let's jump back up and take a look at the property called the power property. Okay, we have yet to deal with a logarithm that hasn't had a coefficient of a 1, but there'll definitely be types of logarithms where there might be a number other than 1 in front of the logarithm. And we've said over here that if you're going to combine 2 logs together, you have to have a coefficient of 1. So what the power property allows you to do is it allows you, if you have a logarithm, say, and you have a number in front such as 4, what you're allowed to do is you're allowed to pull that coefficient up and put it in the exponent of your argument. Okay, so in other words, if you have a 4 in front here, you can rewrite it and drag that 4 up so that it reads log base 2 of x to the 4th. Okay, the advantage of being able to do something like that is it then puts a 1 in front of your logarithm and allows you to be able to combine that logarithm with other logarithms that have the same base. So let's come back down to example C, where you can see we have 3 logarithms, but notice that the first logarithm has a 2 in front of it. Okay. When you are combining logarithms, you need to work your way from left to right. Okay. Always start at the left and focus on just trying to combine the first 2 logarithms together. And once those are combined, then you can combine that one with the third logarithm. Okay. Now the issue that we're having here is we can see all 3 of these logs have the same base, but the first logarithm does not have a coefficient of 1. Okay. So what I'm going to need to do here is I'm going to need to pull this 2 up into the exponent. I'm going to pull this up into the exponent of the 5, so that that's going to be log base 2 of 5 squared. Okay. And then I'm going to change that to log base 2 of 25. 25 would be the argument. Okay, and now I can try to combine these 2 logarithms together. I think what you want to focus on is how are you asked to combine the 2 logs together? Well, we're asked to combine these 2 logs together by addition. So if I'm adding these 2 logs together, it means what I'm really wanting to do with the arguments is I'm really wanting to multiply the arguments together. Okay. Now what I have written here is only how the first 2 logarithms look combined. Remember, I still have this third one here. Okay. So for my third one, I've got minus log base 2 of 10. So to combine these together, I see they both have the same base. I see they both have a 1 in front. So if I'm going to combine these together, and again, I think the part we want to focus on here is that we're subtracting these 2 logarithms. So if I'm subtracting these, now what I want to be doing with the arguments is I want to be taking the first argument and I want to be dividing that by the second argument. Okay, so I'm going to always divide the first by the second. And we had said that if you can reduce that fraction, 25 over 10, we would definitely want to reduce that. That reduces to 5 over 2. Of course, keep the x in the numerator there. Okay, so that's kind of how you would tackle if the lead coefficient wasn't a 1, just drag it up into the exponent there. Okay, now we're going to be saving the 1-to-1 property for the next video. Okay, so we're going to focus the next video, we're going to be looking at that. I want to just talk about these last 2 properties here and how to apply those to kind of simplifying some of these problems and just a couple problems on the back here. So we're going to look at these 2 properties kind of go hand in hand. These are called the exponential and the logarithmic inverse properties. Okay, these properties allow you to simplify logarithms. So let's take a look. I'll write down an example here. Log base 4 of 4 to the 7th power. Okay, what I want you to notice here in this example is, do you notice how the base of your logarithm and the base number in your argument are both the exact same number? Okay, this is a special circumstance that if those 2 values are the exact same number, then essentially that entire thing will simply reduce to the number that was in the exponent on your argument. Okay? Now, here's the great thing about this property is this property allows you to write any number so that it looks like a logarithm. For example, let's say that we wanted to write the number 13, but we wanted to write it so that it looked like a logarithm. Well, if I want to write the number 13 so that it looks like a logarithm, it actually doesn't matter what number I use as my base or what number I use as the base in the argument. I need to make sure I'm putting the 13 in the exponent, and the only requirement is that whatever numbers I'm putting in these 2 spots here, they have to be the exact same number. So for example, I could do log base 8 of 8 to the 13th power. That would simplify to the number 13. I could do log base 11 of 11 to the 13th power. That also would reduce to 13. So there's an infinite number of ways that you can take a number and sort of disguise it or write it so that it looks like a logarithm. Now, The reason I'm showing that to you is I want you to look down here to this example that we skipped the then simplify if possible. I want you to focus on the second logarithm. And I want you to ask yourself, since 2 is our base, is there any way that we can write this argument of 32 as 2 to a power? Like, can we make these two numbers here look exactly the same? Okay, well, let's go ahead. I think that if we tried on our calculator, 2 cubed, nope, that's 8. Let's try 2 to the 4th, nope, that's 16. Aha, if we try 2 to the 5th, we end up getting 32. So that means I could rewrite the number 32 as 2 to the 5th, and now these two numbers here are exactly the same. That's what we were talking about right here with this property. If the base number and the base on your log in your argument here are the same number, then according to our property, all this, the logarithm, the base, the 2 in the argument, it all sort of disappears, and the only thing that you're left with for that particular term is the exponent of 5. So we're going to say this is log base 2 of x minus 5. That would be the simplified version of that answer, okay? That's the simplified version of that answer. So let's come down here and try this with example D, okay? You can see in example D, keep in mind the directions here, we're asking you to write this as a single logarithm, okay? Now, some people look at this and think, well, I already only see one single logarithm, but they want there to be only one term here. Okay. There are actually two terms. The 3 is one term, and this other 2 log base 4 of 6xy is a second term. Okay. Things have to look like logarithms if you're going to combine them together. Okay. So I need to write the number 3 so that it looks like a logarithm in order for me to be able to combine it together with the other logarithm, okay? And that's where this property that we were just talking about up here kind of comes into play, okay? So I need these to both be the same number. So I'm going to write this log. Now keep in mind, if I'm writing the number 3 as a logarithm, I need the 3 to go in the exponent. The number that I'm going to choose as my base and as my base of my argument should be the same base that I have over here. So I'm going to make these both 4s, but I'm putting the 3 in the exponent. Okay. Now, you'll notice the second logarithm does not have a lead coefficient of 1. So that 2, we're going to do the power property. You're going to pull that 2 up in the exponent on the 6xy, and you'll need to put parentheses around the 6xy so that in the following step here we can distribute that. Okay, so we're getting this looking better, so things are starting to look like logarithms. They have the same base. We need 1s in front. Let's go ahead and combine this together so that we have log base 4 of 64 minus log base 4. I'm going to distribute that exponent. Okay, now we got the same base, we have 1s in front. I'm looking, oh, we're subtracting these. So I'm going to write this log base 4 of 64 over 36x squared y squared. Okay, now I just need to simplify 64 divided by 36. That's going to reduce to the fraction 16/9. Of course, you want to keep the x squared y squared in the denominator. Okay. All right, one last property. One last property that we're going to look at here is this property right here. Okay, and this is just another simplifying property here. If you have a base number like 2, and then in the exponent of that 2, you actually have a logarithm. If your base number matches the base number of your logarithm that's in the exponent, then again, everything kind of disappears out of your term except the argument of your log. Okay? Now I'm mentioning that because we're going to see that property pop up on a few of these examples on the next page, and this is going to be the place where we're going to go ahead and stop. So let's go ahead and flip to the back here. We're going to look at these 3 examples, and then we will fill in the rest of the notes on the next video. Okay. The bulk of these 3 problems are having us use these 2 properties right here, okay, these 2 simplifying properties. So let's look at example 3a. Okay, we had said that if the base of your log matches the base of your argument, if those are the same, that's going to reduce to your exponent of 4. So I'm going to change that to a 4. Okay, now I'm looking here and I'm seeing that my base on my log, it doesn't match the base of the argument. But you have to ask yourself, can you make the 64 look like a 4 raised to a power? Well, yeah, I think that a 4 that's cubed is the same thing as a 64. So let's write the 64 as a 4 cubed. Keep in mind we still have that 10 that's out there. So we'll want to ultimately change the exponent to be a 30. Now that these are both the same, all that cancels, and we're left essentially with the number 4 minus the number 30. The answer to this is just the number -26. Okay, keep in mind, there's no logarithms here anymore. Do not try to divide these numbers. You only divide arguments of logarithms when you're subtracting. There's no logarithm here. You are just literally subtracting 4 minus 30. Okay, in example B, this is the other property here where if your base number matches the base on your log in the exponent, everything should reduce to that argument. That becomes a 4. Over here, you want to ask yourself, can I make this 25 look like a 5 raised to a power? So I'm going to make this look like log base 5 of 5 squared. Now, those look the same. So that means that this is going to reduce to the number 2. So essentially we have 4 plus 2. My answer is 6. Okay, last one. Can I make the number 32 look like a 2 raised to a power so that those are the same? Sure, we can write it as 2 to the 5th. Okay, so my other logarithm here, as long as these are the same, I can reduce that to a -3. That leaves me with 5 minus 3. The answer is 2. Okay, that's going to bring this part of the video to a close. You can go ahead and do those few problems that I mentioned on the worksheet 7475.